Hello and welcome to today's lesson on work done, which is part of the forces topic in GCSE Combined Science Physics. So in today's lesson we should be able to understand how a resultant force causes work to be done. So if we've been successful and learnt in this lesson, we should be able to understand what work done is, calculate work done and power both examination style questions and experimental observations. So in today's lesson we're going to cover the following part of the GCSE Combined Science Physics specification, 6.5.2 work done in energy transfer. Now previously we have considered the impact of an object having a resultant force. So a resultant force causes an object to accelerate in the direction of the resultant force. But a resultant force can also cause energy to change between energy stores. Now this is called work done. Now technically a resultant force causes a change in energy store without the need for a wave, such as light. So when a force moves an object through a distance, energy is transferred and work is done on the object. So when an object changes energy stores without the use of a wave, work is done. So this means work done is another name for energy transferred between two forms, such as from gravitational potential energy to kinetic energy. Now in many examination questions they will ask you to calculate energy transferred and then work done. Do not be tricked, they are in fact the same value. So when a resultant force causes an object to move through a distance, work is done on the object. A resultant force does work on an object when the force causes a displacement of the object, and we can calculate this with the following equation. Work done in joules is equal to the resultant force in newtons times by the distance moved in the direction of the force in meters. Now this means that 1 joule of work is done when a force of 1 newton causes a displacement of 1 meter. So we can say that 1 joule is equal to 1 newton meter, or for example 5 joules is equal to 5 newton meters, or for example 11 joules is equal to 11 newton meters. So work can be done if the object is displaced in the direction of the resultant force. So if an object does not move in the direction of the resultant force, then no work is done on the object. So like we said before, we can define 1 joule as the energy needed to move 1 newton of weight by 1 meter in the direction of the force. We can see this because the work done is equal to force times by distance, so 1 joule is equal to 1 newton times by 1 meter. Now we can do another example of this calculation by working out the work done due to gravity. So we know that work done is equal to force times by distance in the direction of the force. So in this example, if you have a 10 kilogram mass, that can give us a weight or force of 10 times by 9.81. Then we multiply it by the distance moved in the direction of the force, which in this case is 2 meters. So the work done in this example is 196 joules. So this is the work done due to the gravitational force. Now this can only happen when the object is moving in the vertical, as that's the direction that gravity acts in. So if we wanted to work out the work done due to gravity in this example, we would then do work done equals force times by distance, but the distance moved in the direction of the force, in the direction of gravity in this case, is 0 meters, because it's only moving 4 meters horizontally and none vertically. So in this example there's no work done due to gravity, as the object is not moving in the direction of gravity. Now the work done is due to another force, the force working in the horizontal. Now a common example of where work is done in the direction of a force is a particle accelerator. Now in a particle accelerator there are 2 forces found in the accelerator, the magnetic force and the electrical force. Now in a particle accelerator, the only force doing any work and making the particles accelerate is the electrical force, because this is the direction of the movement. Now the magnetic force in this example does not make the particle do any work, as it's not in the direction of the movement. So the magnetic force is there to deflect the particles. Now when work is done against friction, this will cause heat energy to be transferred to the internal energy of the surroundings. Now friction can act as as a resultant force which makes energy change stored in a process. Now, friction can cause some of the energy to be transferred to the thermal energy stores. Now, this will cause the overall temperature of an object to increase, which is shown by rubbing your hands together to keep warm. You are providing a resultant force on your hands with that movement, so that is causing work to be done by overcoming friction, and that allows some of the energy to be transferred to the thermal energy stores, which will cause the overall temperature of your hands to increase. So let's summarize what we've learned in today's lesson. When a force causes an object to move through a distance, work is done on the object. So a force does work on an object when the force causes a displacement of the object. Now, the work done by a force on an object can be calculated using the equation work done is equal to force times by distance moved along the line of action of the force. 1 joule of work is done when a force of 1 Newton causes a displacement of 1 meter. So 1 joule is equal to 1 Newton meter. Now, you should be able to describe the energy transfer involved when work is done, and you should be able to convert between Newton meters and joules. Now, work done against the frictional forces acting on an object causes a rise in the temperature of the object. So if we've been successful and learnt in this lesson, we should be able to understand what work done is and calculate work done and power for examination style questions and for experimental observations. So I hope you've enjoyed today's lesson where we've looked at work done, which is part of the forces topic in GCSE Combined Science Physics. Thank you very much for watching and have a lovely day.